technology to prevent our own extinction by an asteroid. The power to wipe out our species with an engineered super disease. The battle against cyber terror and the double-edged sword that is genetic engineering. Now, more Doomsday tech on Modern Marvels.
Welcome to the year 2012. This insignificant space rock, a pockmarked orphan from the birth of our solar system, is about to exterminate the human species. It's a backdoor asteroid masked by the light of the sun and able to slip past the sparse telescopes in our southern hemisphere. 8 kilometers in diameter, it hurtles through space at 44,000 miles per hour. In a split second, the asteroid shoots through our atmosphere and makes a land impact. It releases the equivalent of 44 million megatons of TNT, 8,000 times the destructive power of the world's entire nuclear arsenal.
It can really screw up the whole planet. First, with a big explosion, then with lifting material up, blasting it off the Earth, and it then falls back down into the atmosphere where it bursts into incandescence and the whole planet is enveloped in a firestorm with the forests and the grasslands burning. And then finally, by leaving much of this dusty material in the stratosphere where it blocks the sunlight and plunges the entire planet into darkness and cold that might last for years. It is this kind of environmental catastrophe that leads to a mass extinction.
It wouldn't be the first time a successful species was destroyed by a rock from space. Most scientists now agree that the extinction of the dinosaurs and countless other species 65 million years ago was caused by an asteroid or comet, up to 10 kilometers in diameter, that struck off the Yucatan Peninsula.
99% of the species that have lived on Earth are now extinct, and many of these went extinct at mass extinctions, at catastrophes in which the whole planet was affected.
The evidence of violent impacts throughout our solar system reminds us that it's not if, but when.
The Earth has been battered by impacts throughout its existence. If you want to get an idea how many impacts have happened on Earth, just look at our companion, the Moon, which is covered with craters.
By far, the most common cosmic warheads are asteroids.
Well, an asteroid is a rocky body that's left over from the inner solar system formation process. And that material that didn't form into Mercury, Venus, Earth, and Mars were the leftover asteroids.
It's only within the last 20 years that astronomers have become aware of just how many Doomsday-sized asteroids are swarming all around us.
There's thought to be about 1,100 near-Earth asteroids, as we call them, that are 1 kilometer and larger. They come down from above, they come up from below. Their orbits are inclined to the plane of the Earth. This orbit, the Earth is making its leisurely course around the sun, running through this cloud of near-Earth asteroids.
The odds of a planet threatening 1 kilometer impact in this century are 6,000 to 1. But asteroids big enough to destroy a city come within 30,000 miles every few years. In either case, the potential consequences are so great that a handful of astronomers decided to do something about it. Asteroid hunting was born.
Today's Space Guard survey, supported by NASA, is concentrating on finding the objects larger than 1 kilometer in diameter, because those are the ones that could risk a worldwide, global catastrophe if they hit.
Since the first serious asteroid hunts began, the crucial tools have been a telescope and a camera working together.
The search is carried out with relatively small telescopes, but very sophisticated detectors and computers, so that we can automatically detect the little faint moving image of an asteroid against the background of millions of fixed stars.
with the electronic cameras that we have and the Quest camera that we are currently using, with 112 cameras in one. We scan 20,000 images a night and completely analyze those in a night.
The state-of-the-art Quest camera, located at California's Palomar Observatory, is the world's largest digital camera. It uses CCDs, or charge-coupled devices. Each CCD contains millions of pixels, each of which converts the light it receives into electrons. Each pixel's electron reading is given a precise digital value. Then all the digital information is reformed into an image.
We report what we observe, and then computers grind away at collating all the information that comes in from a large number of telescopes, and then plots the orbits of these things over a period of time, and then from those orbits you can infer whether it's going to strike the Earth or not.
NASA's Space Guard program has tracked most of the large asteroids that could cross the Earth's path. And so far, so good. Nothing appears to be on a collision course. However, about 30% of our skies have yet to be surveyed for asteroids, mostly in the southern hemisphere, where there are far fewer observatories dedicated to the task. In 2002, an asteroid big enough to destroy an area the size of Ohio came out of the southern skies and passed extremely close to Earth. Only twice the distance as that to the Moon. Astronomers had seen it coming only weeks earlier.
The reason we're carrying out the Space Guard program is not that the probabilities are high. It's that there could be an asteroid headed for Earth. If it's going to hit Earth next year or next decade, it's already on a collision course. And we have the technology to find out and take action to protect our planet.
So how do you stop a large asteroid from hitting the planet? Astronomers favor diverting the asteroid over destroying it.
You can try and break it up Bruce Willis style, but then you've got this shotgun effect that's simply going to cause more damage. If you actually mount a shuttle engine, for example, on the surface of the asteroid, you'd want to thrust in this direction, so you move the asteroid a little bit in that direction. But the problem is, the asteroid's turning. So you'd have to thrust there, wait a while until it comes back around, thrust there, and so on. And you can actually have a mass driver, they're called, anchor it onto the surface of the asteroid, electrostatically throw rocks from the asteroid off, and introduce a thrust that would slow it down or speed it up.
A more viable current device, called a solar sail, would use the sun's energy to alter the asteroid's path. But it would still involve building a base on the asteroid's surface. Not an easy task.
What you'd really like to do is get off the surface and introduce perhaps a solar concentrating mirror. So if you take the sunlight with your mirror and you reflect the rays and concentrate the rays onto the surface of the asteroid, you can actually ablate and vaporize the front surface and introduce a small outgassing in this direction and a thrust in this direction.
At NASA Langley's Comet and Asteroid Protection Program, scientists have modeled a moon base to track and divert a Doomsday asteroid. A telescope on the moon could see the entire sky without atmospheric interference. And nestled, ironically, in a deep crater, it could avoid sunlight at all hours, allowing for constant observation. Once it had the asteroid or comet in its sights, the moon base would focus a laser on the target, generating enough heat to thrust the rock off course. Some of these technologies would be decades in developing. And lest we feel too confident, there's still the risk of the ultimate cosmic sucker punch, the comet. Comets, giant balls of ice and rock, have erratic orbits and emerge unannounced from deep in the solar system.
If we should happen to be really unlucky and have a comet headed our way, we would probably have only a few months, at most a couple of years of warning. And in that time, I can't imagine that we would have any technological approach to protecting ourselves. The best we could do is just hunker down and let it hit.
In 1994, human beings for the first time were able to observe the destructive power of a comet in our solar system, when fragments of the Shoemaker-Levy comet collided with Jupiter. The impact cloud was as large as the Earth.
That's the bad news. Good news is there are so few of these comets that we really need to worry about the asteroids first and then deal with the comets, which are far more difficult to deal with later.
With a little luck and our big brains, human beings may be able to avoid the fate that has befallen other mighty species.
The reason that the dinosaurs checked out some 65 million years ago is because they didn't have a space program.
Threats to our species can come from the far reaches of our solar system, or from microscopic weapons inside our bodies. The age of bioterrorism has arrived. The greatest mass extinction ever, the Permian Triassic, or Great Dying, wiped out nearly all life on Earth 250 million years ago. Recent evidence, while sparse, suggests a giant asteroid is the cause. More Doomsday tech will return on Modern Marvels. In the weeks after September 11th, a stunned United States was rattled by another series of attacks, employing not large commercial aircraft, but microscopic spores of Bacillus anthracis, anthrax. 5 people died as authorities scrambled to find the source of the attack. Scientists from the Centers for Disease Control and the U.S. Army Medical Research Institute of Infectious Diseases, or USAMRID, immediately began analyzing the anthrax samples. While examining the spores from the letter sent to Senate Majority Leader Tom Daschle, they made a shocking discovery.
I and my team looked at it by scanning electron microscopy just to get an idea of what its nature was, and we were amazed at how concentrated and how purified this material was. The observation was made very early that the powder seemed to be very energetic. It just sort of floated like smoke.
This was exceptionally pure and well-engineered anthrax. The spores had apparently been treated with an electrostatic charge, so they repelled each other rather than clinging together, making them easily dispersed and inhaled. The 2 grams of bioagent found in the Senate building contained 1 trillion spores per gram. If it could somehow be perfectly dispersed, that's enough to provide 200 million lethal doses. Doomsday technology in an envelope.
If a terrorist wanted to create mass casualties with anthrax powder, he would probably disseminate it as an aerosol plume, not delivering it in envelopes. It could be released in an open area through a crop duster or some such thing. If he had more limited quantities, it would probably be introduced into the HVAC of a closed airspace like an office building.
The anthrax attacks forced the world to acknowledge a new lethal combination of technology and technique: biological weapons and terrorism. A bioweapon's effectiveness can be measured in terms of lethality, ease in manufacturing, and infectivity. Anthrax, while lethal and relatively easy to manufacture, cannot be transmitted from one person to another. Other bioagents are only moderately infectious, but extremely lethal, like Ebola.
Ebola is a viral hemorrhagic fever. It is fatal in 50 to 90% of the cases, which makes it extremely lethal. But actually, it is not as easy to transmit Ebola from person to person as it is to transmit smallpox.
Smallpox may be the true bioterror doomsday device. The dreaded scourge that killed over 1 billion human beings through the centuries could return as a weapon.
The year 2014. 10 suicide terrorists infect themselves with a highly virulent strain of variola major, smallpox. Walking through international airports, subways, and malls, they infect 20 cities in 4 continents within 48 hours. 10 days later, the first symptoms hit America, Europe, and the megacities in India and Brazil. Without enough vaccine to immunize the world, millions die. The smallpox virus, once eradicated worldwide, is back.
Smallpox was targeted for global eradication by the World Health Organization in the 1970s. Global eradication was declared a success in 1980. At that point, naturally occurring disease had in fact been eradicated from the planet, and we would have been free of smallpox entirely had it not been for the Soviet weapons program, which developed smallpox as a biological weapon.
Today, the smallpox virus exists officially only in two places: at the Centers for Disease Control in Atlanta and at the Vector Institute in Siberia. But that is a rosy picture, considering the vastness of the former Soviet bioweapons program.
That program reached its full strength in the mid-1980s and continued until it was essentially shut down in 1990. The problem is that with literally ton quantities of smallpox virus being produced, it's unimaginable that all of that material was actually destroyed.
The Soviets reproduced over a dozen lethal bioagents in ton quantity, including a genetically modified antibiotic-resistant strain of plague. But smallpox was the most massive project. A particularly virulent strain, called India 1, was cultivated inside a 300-gallon tank called a bioreactor. Inside, living monkey cells were maintained at the temperature of blood. Cell nutrient fluid and variola virus were pumped into the bioreactor, creating a perfectly engineered smallpox breeding ground. One batch could produce 100 trillion lethal doses of smallpox, and they made thousands of batches. The Soviet bioweapons industry, while by far the world's largest, wasn't the only advanced biowarfare program.
America did have an offensive biological weapons program. It was during the height of the Cold War, and it was discontinued by President Nixon in 1969.
Between the 1940s and the late 1960s, the United States produced significant amounts of anthrax, plague, botulinum, and a host of other agents. Many were tested in the million-liter sphere, known as the 8-ball, at Fort Detrick, Maryland. Deadly agents were aerosolized, and spores and powders were packed into bombs and artillery shells. With these doomsday devices long ago dismantled, Fort Detrick today stands at the center of the battle against bioterrorism. Scientists here and at the CDC are doing their best to prepare for the worst. According to Russian scientists, the Soviet Union had developed an ICBM equipped with 10 warheads that could each release up to 4.5 pounds of smallpox mist over an American city. More doomsday tech will return on Modern Marvels. There are many strategies in the preventive war against a doomsday bioterror attack. The first is knowing your enemy, the disease. With highly contagious lethal diseases like smallpox, acquiring hands-on knowledge is a deadly serious task.
Smallpox has to be studied under what's called BSL-4, Biosafety Level 4 conditions, the so-called spacesuit laboratories, in which they're highly secure laboratory scenarios, so nothing can escape from the laboratory.
These researchers, studying smallpox at the CDC, like anyone entering a Level 4 lab, must first don the plastic biocontainment suit, often called the spacesuit. Every opening on the suit is taped shut, and the shell checked for leaks. Researchers are also tethered to an air supply.
All of the air, both the intake and exhaust, goes through what we call high-efficiency particulate air filter, or a HEPA filter.
The HEPA filter uses ultrafine fibers that can filter out particles down to 1/3 of 1 micron, the size of a small bacterium. Alarms sound if the filters experience a change in air pressure.
Laboratory workers, when they leave the spacesuit area, go through a chemical disinfection shower before they exit the laboratory.
Why do CDC scientists go to such trouble to study these last traces of smallpox?
The smallpox virus is actually voted to be destroyed quite a few years ago by the World Health Organization, and unfortunately bioterror then raised its ugly head. And the decision was made to not destroy them so they could be studied, so that you would not have something that then was in the hands of the bad people and not in the hands of the people that needed to be studying it.
At USAMRIID's Level 4 lab, Army scientists go through the same ordeal to study another deadly enemy, Ebola.
We're interested in the basic pathophysiology of the disease. What is it about the infection with this disease that causes such a serious, life-threatening illness? We are also looking to develop antiviral drugs that are effective against the replication of this virus.
The vacuum-sealed quiet of the research lab is at the heart of the effort to prepare life-saving vaccines and antibiotics. But if the unthinkable should occur, the response will be far from quiet. It will resemble an army mobilizing.
If there were a bioterror attack, there would be a worldwide international response, despite where the attack happened.
The first wave of response would be the CDC's Strategic National Stockpile.
The Strategic National Stockpile is a program within the CDC that prepositions material at selected confidential sites across the United States. The stockpile itself is made up of medical supplies, everything from bandages to hydration fluids to certain vaccines to antibiotics. They are in what are called push packs that can be gotten out the door into any place in the United States within 12 hours.
Teams of epidemic intelligence officers, known as disease detectives, would fly to the affected areas and trace the path of the disease. Mass vaccinations would take place immediately.
We would start out with vaccination in the area that the case occurred, and then you expand out from there. You have several days in which to vaccinate to either halt or ameliorate the effects of the agent.
This same strategy, called ring vaccination, was used by the World Health Organization to eradicate smallpox in the 1970s. Healthcare workers begin at the points of infection and increase in ever-widening circles until everyone who may have been infected is vaccinated. Coupled with this technique would be the use of quarantine.
If somebody were to come down with smallpox infection, they would quarantine the person and everybody that person had come in contact with. Your house, your family, everybody at work would be quarantined along with all of their family. I mean, there would be a really extensive quarantine.
The CDC has quarantine operations set up at 8 major airports and several seaports. In the event of an attack, this will be the main weapon in containing the smallpox demon.
Well, the vaccination uses what is called a bifurcated needle. It's a small dual-pronged needle in which it's pressed into the skin about 12 to 15 times on primary vaccination, and the virus replicates in that wound, causes a scab to form. When the scab falls off, you are immune from smallpox.
The smallpox vaccine is in fact a cowpox virus. The word vaccine comes from the Latin word for cow, vacca. The man who discovered the vaccine, Edward Jenner, observed that cow hands who had contracted cowpox, a much milder form of pox, didn't contract the deadly human smallpox. In today's vaccine, the cowpox virus builds up a person's immune system to the point where it can fight off smallpox. Recent breakthroughs may also cut the doomsday potential of this and other deadly agents.
Well, this is a handheld biosensor that we developed for the Department of Defense. Well, the system is very versatile and can detect a wide variety of different pathogens, including things like anthrax, smallpox, ricin, Ebola.
A drop of the suspected pathogen is placed on this specially designed test strip, which is then inserted into the sensor.
There's a small laser in here, similar to what is used in a CD player, that excites the species on the strip, and it measures the intensity of the light coming out as well as its position, and uses that to determine what species it has detected. It says that it has detected Bacillus anthracis, which is anthrax, with 100% certainty.
Such rapid results could trace the path of an outbreak in minutes, rather than hours or days. And while our high-speed interconnected world may hasten the spread of a disease, instant communication will also be crucial in containing a bioterror attack. Whether it's the CDC's nerve center or healthcare professionals sharing their observations on the internet. In 2003, An online medical forum called ProMed played a critical role in alerting World Health officials to a deadly outbreak in China that would become known as SARS.
China was very slow in releasing any information about SARS because they were worrying about the effect of its going into the World Trade Organization, about tourism, so it became hidden. So I went up on ProMed and asked, anybody else heard anything about this? And within 24 hours, it was acknowledged to have occurred.
Although a naturally occurring virus, SARS stimulated a response that may mirror the defense against bioterror. Within weeks, the spread of the virus that killed over 900 people was contained. The future of bioterror and the tools to fight it may be in the arena of biotechnology. Already, scientists are unraveling the genetic secrets to the deadliest diseases, but the technology may be a double-edged sword. Scientists recently used reverse genetic engineering to resurrect the single greatest plague of the 20th century, the Spanish flu, that killed up to 50 million people in 1918 and 1919. Altering the DNA of a virus now makes it possible, in theory, to design a supervirus that could wipe out large populations. In 2001, scientists in Australia inadvertently engineered a deadly strain of mousepox, for which their lab mice had no immunity.
The concern is that a similar trick could be used to introduce the gene into smallpox virus. And there's the theoretical concern that if such a strain were created, our strategy for containing the disease spread with vaccine alone might be flawed.
If such a grim scenario became reality, we can at least take heart in the knowledge that human beings have defeated seemingly invincible plagues before. Hopefully, we can do it again. The word quarantine is from 40 giorni, Italian for 40 days. It refers to the length of time that ships were forced to sit at anchor before being allowed to enter a port during the Black Death. More Doomsday Tech will return on Modern Marvels, here on the History Channel.
Welcome to the year 2021. Genetically engineered wonder seeds lead to exploding crop yields, nearly eliminating world hunger. But there's a problem. When the wheat seed was modified, a long-dormant gene was activated, causing severe allergic reactions in nearly 3 billion people. Years pass before the connection is made. By then, the world's wheat supplies must be destroyed, and a global food shortage sets in.
It's this type of doomsday scenario that has made genetic engineering, also called biotechnology, the source of angry protest and bitter scientific disputes. Critics accuse industry scientists of deceit in the name of profit. The critics are accused of fear-mongering. Genetically engineered products have been banned in some parts of the world, and yet they're everywhere, from medicine to agriculture and beyond. Engineering with genetic material is already one of the most significant technologies of our young century.
The 19th century was dominated by the age of physics. The 20th century was dominated by the age of chemistry. The 21st century is going to be dominated by the age of biology.
So what is genetic engineering?
Genetic engineering really is the use of what we call recombinant DNA, which simply means being able to cut DNA into very small pieces, cut out just a piece of genetic information and move it from one organism to another.
One of the most widespread and controversial applications of genetic engineering, or GE, is on food. In one sense, genetic modification of plants and animals extends far back into history through the use of selective breeding and crossbreeding. But there's at least one big difference between classical plant breeding and recombinant DNA engineering.
You know, in nature, we can cross some biological boundaries. For example, we can take a horse and a donkey and we can cross them and we'll get a sterile mule. But of course, in classical breeding, we can't cross a horse and an apple tree. The point here is, in theory and practice, we can now cross all the biological boundaries.
So you can take genes from bacteria, viruses, animals, plants, and humans and mix them. You can take a gene that creates antifreeze from a flounder and put it in tomato so the tomato will not react to frost.
Here at UC Berkeley, my laboratory focuses on doing genetic engineering of cereal crops like wheat, barley, rice, corn, sorghum. We're involved in a developing country project with Africa trying to improve the nutritional quality of sorghum. There are other projects that we work on that are more directed toward perhaps consumers in the United States, because we work on a project where we're trying to develop a hypoallergenic wheat. That is a wheat that people who otherwise are allergic to it and can't eat it would be able to eat.
Creating the raw material for genetic insertion happens inside this small machine that has revolutionized biotechnology. It's a polymerase chain reaction, or PCR machine. Inside, enzymes called polymerases synthesize an unwound strand of DNA. In 45 minutes, it can generate millions of copies of a specific DNA sequence. A device called a gene gun then blasts the DNA from the foreign organism into the host organism.
You use tiny little pellets, about 1/30th the size of an actual cell. You coat that pellet, which is actually made of gold, with DNA. You shoot it at a very high speed, about 600 miles per hour, down a chamber. And at the bottom of the chamber are plant cells. And those little tiny beads go inside of the plant cells and end up inside and become incorporated into the DNA of the plant cell.
The gene gun also injects a genetic promoter, which makes sure the new gene is permanently switched on. And there you have it, a genetically modified organism. For critics, the promoter is just one of GE's problems.
The promoter turns on the inserted gene permanently, but we now know that it can potentially turn on other genes inside the DNA permanently, which can create all sorts of things: allergies, toxins, new diseases, carcinogens, anti-nutrients, or things good. We don't know what'll happen if we change the DNA of our own organisms or of our gut bacteria.
It's the unknown that causes critics of GE to urge caution. Unintended effects have been a common result of genetic engineering since it began.
When genetically modified cotton was first introduced, many of the cotton balls just fell to the ground. Genetically modified soy cracked in the sun. These are examples that when you make changes at the fundamental level of the DNA, it's not like Legos. We don't just snap a gene into place and get one desired trait.
In 2000, a brand of genetically engineered corn called Starlink, which had been approved for animal but not human consumption, became mixed with human corn supplies in grain silos. Starlink, which was engineered to produce its own pesticide, caused widespread allergic reactions, some severe. After the contaminated corn was destroyed, losses stood at $1 billion.
It was found in 22% of all samples by the USDA. And even after millions and millions of dollars and $1 billion loss from Starlink, 2 years later it was still found in over 1% of the samples collected by the USDA.
But perhaps the biggest surprise for genetic engineering came in June of 2000, when scientists from the Human Genome Project made the shocking announcement that our genome contained only 30,000 genes. Up to that time, the human genome was assumed to contain 100,000 genes, each producing one of the 100,000 proteins known to make up the human body. But the numerical gap made it clear that many of our genes perform more than one function.
It was a wake-up call. The foundation of genetic engineering is that they can introduce one gene into a species, it'll create one protein, it'll be the desired protein, it'll act correctly, and this foundation was destroyed when scientists acknowledged that a single gene can produce more than one protein.
Critics say such a basic miscalculation of the human genome raises doubts about the precision with which any genes can be spliced, especially when dealing with the world's food supplies. Studies have shown the potential for unforeseen consequences on human health, or on the crops themselves, which then infect non-GE crops with the spread of their pollen. But chances are you've eaten genetically modified food at least once today. 85% of the U.S. soy crop is GE, along with 76% of the cotton crop and 40% of corn. Where do soy protein, cottonseed oil, and corn syrup end up?
It's estimated that about 75% of the processed foods actually contain some element from a genetically engineered organism.
Proponents of GE food believe this is proof of its safety.
When I think of food safety issues, and I mean, I know the science pretty well, I'm not concerned about long-term food safety issues. When we do genetic engineering, we go in and pick out a particular, I call them recipes, and we can actually read that recipe. We know what's in that recipe. And so when we pull it out and we stick it in, we can be pretty predictive. We can't predict everything, which is why then it undergoes many years of testing in order to see if there is any other consequence of making that.
But opponents point to a distinct lack of testing on GE foods.
There was a doubling of food-related illnesses in the United States, according to the Center for Disease Control, between 1994 and 2001, corresponding to the introduction of a lot of genetically modified foods. We don't know if the two are related, but it makes sense that we shouldn't have introduced these foods into the market without thoroughly testing them. It's not appropriate to feed the products of this infant science to millions of people or release them in the environment where they can never be recalled.
Millions of people have come to the same conclusion. In 1998, the European Union called for a 5-year ban on new GE products, and a debate rages over whether to reinstate the ban. Cutting-edge technologies often reveal a dark side. Just as biotech raises the specter of doomsday crops, the digital age is haunted by the prospect of cyber terror. In 2002, despite a major food shortage, Zambia refused to accept almost 30,000 tons of genetically engineered grain donated by the U.S. The U.S. later sent non-GE grain. More doomsday tech will return on Modern Marvels.
It's the year 2016. Terrorists, thwarted by military means, refocus their resources into cyber attacks against the United States. They wreak havoc on major banks, Wall Street, and the Federal Reserve. The U.S. is kept in a state of economic stagnation. Emboldened, the terrorists achieve the unthinkable, hacking into the nation's nuclear command and control. They mimic a Russian attack. Dozens of U.S. and Russian missiles are launched before the false alarm is recognized. By then, it's too late.
Most cyber terror experts agree that the idea of terrorists hacking their way to World War III is highly unlikely. But coordinated cyber attacks could inflict significant damage to our infrastructure and even cause loss of life.
Every computer network is vulnerable. There's no such thing in the world as a 100% secure system. Period.
We are totally dependent on computers today. If all the computers, in fact, if even just the intelligent computers doing things that used to require human intelligence, stopped functioning, our society would grind to a halt.
To wreak cyber havoc, it's mainly a matter of getting in.
What we're about to do is we're going to show you how easy it is to break into a network. So, for all argument's sake, let's pretend we're on Wall Street. We're outside in a car. So if we are detected by the firewalls and the IT managers realize, hey, something's going on, and we find out that they know, we can just drive off and they'll never know. What we're looking at here is a program that's available on the internet. It's free. What this program shows you is all the available networks in our local area. This one shows that there's strong signal strength. Let me show you what the signal strength looks like. This right here, all this in green shows that we have a good connection to this particular wireless network. We also see here that there's an IP address for this particular one. So now that we have this person's private IP address, we're going to hack into this person's network.
The final line of defense is the passcode.
There's plenty of programs that can crack passcodes, especially the wireless networks. Today, we're going to use one that's going to allow us to crack the passcode to this particular wireless network. Entering the information. And here we go. It just cracked this person's passcode or encryption code to get into their network.
Once a network has been breached, it can be used to hack into other networks.
We can go hack the Pentagon. We can go hack a financial institution. And if they trace it, they track it. They're not going to track it back to us, they're going to track it back to the network that we broke into and use to break into their network.
The methods used to crack into secure networks don't vary a great deal on the hacker hierarchy. Only the resources and the level of malice. Lowest on this scale are what cyber experts call the ankle biters.
Ankle biters are often the teenage kids we hear about, the hackers that are defacing websites or breaking into computer systems sort of for thrill and games.
Then you have computer hackers that you never hear about. These are the guys who are paid computer hackers. They make their living as computer hackers. They break into a bank, steal millions of dollars, and send it to the Cayman Islands and then wire it to 5 different banks.
Sir, we have a missile event.
The most malicious form of cyber attack is termed information warfare.
What we're trying to do is defend our systems from information warfare attack. We really want to distinguish between the kinds of attacks that the teenage kid hacker could do and the kinds of attacks that we term from a well-funded nation state. So some well-funded entity is going to launch some concerted attack against our information systems.
In 2003, a skillful cyber attack infiltrated Fort Campbell, headquarters for the Army's elite helicopter units. The attacker monitored the base's network activity for months. Damage to national security has not been disclosed.
We certainly have seen evidence of large-scale attack being launched against the United States.
One of the most widely used tools to thwart a cyber attack is a firewall. A firewall is either a software program or, ideally, a piece of hardware that filters all outside visitors to a network.
We discovered over time that no prevention technology is quite strong enough. You can't build a wall that's totally impenetrable. So then the technology really moved towards detecting intrusions. So we went from preventing to detecting.
Detection of a cyber attack is about to enter a new age with the advent of quantum cryptography. Its sole defense against intrusion, a single photon of light.
Heisenberg's uncertainty principle tells you that if you measure a very, very small thing, like a single photon of light, you change it, you destroy it when you do that. And that's the secret behind quantum cryptography.
Cryptography, the practice of masking sensitive data with random numbers or letters, is the key to internet commerce and communication. A standard network uses large prime numbers that are difficult to factor, but not uncrackable. In the quantum cryptography experiment, photons are pulsed through underground fiber optic cables, acting as sentries ahead of streams of information. Any intrusion will destroy the photon and alert the network to the hacker.
If you have only a single particle of light and somebody is eavesdropping on it, by the very act of looking at it, they destroy it. And then there's one additional interesting fact, which is you cannot make an exact copy of the quantum state of a photon. So they can't grab it, copy it, and send you a copy.
The major hurdle has been sending the photons more than about 50 miles, since photonic energy dissipates over fiber optic cables. When that hurdle is cleared, hackers beware.
With quantum cryptography, it would take the hackers a long time to even learn the ABCs of what we're doing. But once they've learned those ABCs, we believe this is actually protected by the laws of physics. There is no way around this.
From computers to biotechnology to disease research, all double-edged 21st century technologies are subject to deliberate abuse and unintended consequences. And yet the benefits of advanced technologies may outpace the dangers they bring. We may one day have the means to defeat the Doomsday Rock with our name on it. Or we may rapidly exit the world stage through our own devices. 99% of the species that have ever lived on Earth are now extinct. Only time will tell